So I just made the whole video, but I forgot to press record, so I have to do it all over again. Yay, Friday, I get to do 2 videos. Alright, so first question was about finding the coordinates. Good thing is, I know the answers now. There was a fire station. That goes over here. And there's also a hospital. Okay, so let's get to that. The fire station is 6 over, 7 up. And the hospital is 10 over, 7 up. And they're asking you what coordinates that they share. Well, they don't share this first one, the x-coordinate. They're different. One's 6 over, the other's 10 over. But they both share 7, the y-coordinate. They're both 7 floors up. Okay? So they both share the y-coordinates. 2. On the map above, locate the location of the... okay, so now there's a bank. And they give you clues as to where the bank is located. So let's see if we can find where the bank is. The bank has the same first coordinate as the fire department. So 6 is the first coordinate for the fire department, so is the bank. So the bank shares that. But the second coordinate, which is this one, the fire station. So the bank shares the first, but it's the second coordinate. It's half of what the fire station is, and half of 7 is 3.5. Yes, you can have 3.5. You can have 3.1 on the coordinate plane. So where's the bank? The bank would be 6 over, 1, 2, 3, 4, 5, 6, and 3.5 up, right about there. Okay, and you would write a number letter B there. Okay, bottom one. There's a police station as well. The police station has the same second coordinate as the bank. So the bank's second coordinate is 3.5. So the police station also has 3.5 as its second coordinate, but its first coordinate is -2. So the police station is a little bit further away. It's on the opposite side. It's -2 to the left, 2 space to the left, and 3.5 going up, right about there. And you can call that point P. Okay, simple question. 25 or page 25. Okay, so here you are going to be asked about quadrants. Here's my coordinate plane. I'm going to draw one here. Put arrows on each ends. This is my x-axis, my y-axis. You always need to label them. Okay, so it says write the coordinates at one point that lies in the second quadrant. Well, let's label our quadrant. That's quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4. So it says pick any point. Well, let's create one. Right here. Let's call that A. So A is at -2, 2 over to the left, and 1 up. Okay. And it says what must be true about the coordinates of any point that lies in that quadrant. Alright, so any point. All these points that I'm making. Quadrant 2. What do they all have in common? One thing that they all have in common is that the first coordinate, okay, let me write that a little better. The first coordinate, the first number of that ordered pair will always be a negative. And the second number will always be positive. Okay, so think about it. If you're at the origin, you will always walk to the left, which means you're negative territory. And you will always be going up, which is positive territory. So it's always going to be a negative first, and always be a positive second. Okay. So 3. An ordered pair that has coordinates have the same. Or 2b. What must be true about the coordinates of any point that lies in the third quadrant? Well, here's the third quadrant. Okay. Any of these points. Okay. And this one, and this one, and this one. What is true about all of them? Well, one thing that's true about them is that they all, if you start at the origin, to go to any of those green dots, you always have to walk left, which is negative territory. And you always have to go down, which again is negative territory. So the first number will always be a negative, and so will be the second number. Okay. Question 3. An ordered pair has coordinates that have the same sign. second number is positive, or first number is negative and the second number is negative. So what's true? In which quadrant would they lie? Well, if it's positive, positive, every point in here, and I'll choose yellow, all these points in quadrant 1, they are always going to be positive, positive. You're always going to go right, which is positive, and you're always going to go up, which is also positive. So their numbers will be positive number, first, and second number will always be positive. Second will also be positive. And then also, I'm sorry, and I forgot, negative, negative. Negative, negative, we just did that, will be in quadrant 3. Okay, 3A. Or 3B, I'm sorry. What if they're opposites? Well, if they're opposite, we're talking about one sign that's positive, one is negative, or one is negative and the other one is positive. If the first one is positive and the second one is negative, it means that we're talking about points in quadrant 4. And if the first one is negative and the second one is positive, we're talking about quadrant 2 again. Okay. 26. How are the other pairs 4, 9, 4, negative 9 related? Also, what I create. You can do this hopefully on a graph paper so you can see it better than I do. Okay, but let's do it. 1, 2, 3, 4, and it tells you 9. Go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 and 9 would be about there, roughly. And 4, negative 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. 4, negative 9, comma, negative 9. How are they similar? How are they different? Well, they're the same. How are they the same? Because they're both, to get to either point, you have to walk right, 4 to the right. That's how are they same. How are they different? Well, they're different because one you have to go up 9, the other one you have to go down 9. That's how they're different. Okay. How are they related by reflection? Well, they're reflected over the x-axis. You notice both points are 9 spaces away from the x-axis. This is 9 spaces away, and the top point is also 9 spaces away from the x-axis. Okay. Question 2. Again, let's draw this out best as I can, or you can. And we want negative 5 and 2. 1, 2, 3, 4, 5. Negative 5 and 2 go up 2, about here. Okay, this is my x, this is my y, so this is negative 5 and 2. And then on the other hand, okay, we want to write the coordinates of a point as related by the reflection over the x or y-axis. Okay, so let's do both. We want to do a reflection over the y-axis. It means we have to jump this line right here. So negative 5 and 2 is going to end up on the other side. 1, 2, 3, 4, 5. Okay, it's going to be about here and go up 2. That point is called 5 and 2. They're both 5 units away from the origin, from the y-axis, I'm sorry. From here to here is 5 spaces, and from here to here is 5 spaces. What if we did a reflection over the x-axis, which would be from here to here? We're jumping the x-axis, and we have to go 1, 2, would be right here. This would be negative 5 to the left, and instead of going 2 up, it would be 2 down. So this green dot right here is 2 spaces away from the x-axis, and this black dot over here is 2 spaces, also 2 spaces away from the x-axis. They're a mirror image of each other, okay? Same distance away from each other. Pretend the x-axis is the mirror. Okay? 27. Okay, 27, I can do this. Press that button, press that button, press this button, and blah, 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 blah. Here we go. And down, paste, They want us to create a graph here, okay? I guess the point is to make sure that you use the appropriate scale. Right? You'll see what I mean in a second. So here we go, and we'll choose a color. Okay. First thing, okay, even with this, arrows, arrows, Y, arrow here, X. Okay. Now, if you look at your numbers, the first number in each ordered pair, 1's 10, negative 25, 0, negative 20, negative 5. So, in the X line, you need intervals. You can't use 1, 2, 3, 4, 5 because we're going to run out of room. So therefore, you got to pick another scale here. And the scale I'm going to pick is 5, 10, 15, 20. I'm going to skip by 5. So on the other side, I will skip by 5s too. Negative 10, negative 15, negative 20. And up and down, which is your Y coordinate, notice that your numbers are very tiny. They're less than 1. So you can't do this, and I'm going to erase this, call this 1 and 2, because it makes no sense. We don't need numbers that go as high as 2. Okay. What we can do is make these, each square is going to be 0.2. Okay. 0.2. This one is 0.4. This one is 0.6. This one is 0.8. Going down, same thing. The first box is negative 0.2. Second one is negative 0.4. The third one is negative 0.6. The fourth one is negative 0.8. Well, let's find our number. See, I hate this problem because it makes it so ugly. All these numbers are there. It makes it really difficult for you guys to see. So it's not really the best question. But it's about scales, okay, and knowing what intervals to use here. Okay. So the first number, 10's negative 10, positive 10. So 10 to the right. 0.2 up. So this would be the first point. Let's call that A. Second point, negative 25, which is to the left, negative 25 over here. And you want to go up 0.8 floors. All right, and then next one is 0 and negative 0.4, which is right here. D is 20, 20 to the right, and 1 up. 1 up would be all the way up here. And finally, E is negative 5, which is to the left, and negative 0.8, which is all the way down here. Okay, we'll call that E. Not so much. I don't like the question. Okay. 28. Okay, 28. Determine whether each given pair of endpoints lie on the same horizontal or vertical line. So find the length. Find the length or how far they are from each other. Okay. 0 and negative 2, 0 and 9. I know, without graphing, that they're both here. How far is this from each other? It's 0 spaces away from each other. No, I'm sorry. What am I talking about? They are 11 spaces away from each other. And I'll show you how. I know. So, let's make this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 point, 0, negative 2 is zeros. Don't go left or right, but go 2 down. So let me put it right here. The other one is, again, at 0. Don't go left, don't go right, but go 9 floors up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So one person is on the 9th floor, and the other person is 2 floors underground. How far are they from each other? How do I know it's 11 floors? The distance between them is 11 floors. Well, if you're on the 9th floor, you'd have to agree with me that to go to the ground level, which is here, the middle, ground level, okay? Pretend you're taking elevators. If you're on the 9th floor and you're going to ground level or level 0, you have to go 9 floors down. Agree? And then from there, if you want to go to 2 more floors down, which is where your car is, floors under your building, you have to go another 2 floors down. How many floors in total? 9 and 2, 11. Okay, so you're really adding the distance between this point and the x-axis and distance between this point and the axis. This is 2 spaces away, this is 9 spaces away, and 9 and 2 is 11. Okay, they share the same vertical line. Okay, they're both here on the vertical line. Okay, 11 and 4. Little delayed reaction there. I don't know why it does that. So 11 and 4, which means go 11 to the right and then 4 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4. So it would be around here, roughly. Okay, and the other one says go 2 to the right and 11 up. To the right, let me change color. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It would be right here. Are they? Do they share the same? Sorry, what is it? 11 and 4. They share the any of the coordinates. This is my x coordinate. This is my second x coordinate. There are. Actually, I wrote this backwards. This is 4 and 11. No, right. This is what the heck? 11 and 4. Right. Did I just do this completely wrong? No, that's right. 11 and 4 to 11. All right. So this was right. Why did I write it different? Oh, the second one I wrote wrong. Sorry. And once again, 2, 11. Right. So let's go back to this. So look at your x coordinates. This x coordinate is 2. This x coordinate is 11. They're different. This y coordinate, one is 11. The other one is 4. You can tell they're not in the same horizontal nor vertical line. So to calculate the distance, there is a way, but we're not going to do diagonals. Okay, so for this one, okay, that's it. C, 3 and -8 and 3 and -1. So here we go. 3 and -8 means go 3 right, 1, 2, 3, and we're going to go, let's make arrows, X, Y. So we go 3 right and 8 down. 1, 2, 3, 4, 5, 6, 7, 8, right here. So here's your 3 and -8. And then we're going to go 3 and -1, and 3 and -1 right here. This is your second point. What coordinate do they share? They share this, the 3 together. The x coordinate. So this is, they share the same, and I'm going to do it in red, the same vertical line. How far away are they from each other? That's very easy. One's a -1, the other one's a -8, so it should be the distance of 7 from each other. All you gotta do is count from one dot to another dot. And we have one more. Oh, we have, and again, I'll draw one. Again, you're better off doing this on a coordinate grid. Okay. You didn't learn how to add and subtract integers. That's why this question is better done on a graph. Okay. So -4 and 4. So -4 to the right. 1, 2, 3, 4, and -4 down. 1, 2, 3, 4. And where do they meet? Right here. So that's point A. -4 and -4. And the second one, you're a you're a 5 and -4. So it means 1, 2, 3, 4, 5, and then 4 down. This is 5, -4. They share anything? Yes, they do. Y coordinates. They both share a horizontal line. They're on the same horizontal line. Oops, horizontal line. And how far are they from each other? Well, you can just count. From here to the y-axis is 4 spaces. From the y-axis to this point is 5 spaces. So a total of 9. You can count. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how they are, how far they are from each other. And I think we have one more page. The coordinates of one endpoint of a line segment are -2, -7, and the segment is 12 units long. Okay. Give 3 possible coordinates of the line segment's other endpoint. Okay. Actually, I have to. Here's my y, and there's my x. Arrow, 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 y, and x. All right. So -2 and 7. So -2 and 7 will be to the left. 1, 2, and 7 down. 1, 2, 3, 4, 5, 6, 7. Right here will be -2 and -7. Read. And why is my screen so slow? Who knows? Okay. That's one end of your line. Now they said that the other end, okay, you're going to create a line, but the other line has to be 12 units long. So let's do that with red, and let me do this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just make another one. So you want to create another dot that's 12 spaces away, either left or right or up and down. Or if you're going up and down, okay, you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It'd be right here. And where's the location of that? It's going to be -2 and 5 up. This point right here is 12 spaces away from the original point. If you want to go left and right, I just say that. First one's up and down, this one's left and right. You're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And you're going to create a point that's a little bit further out that way. And that point is going to be 10 and -7. Let's see if that works. Well, it's here, it's 2 spaces. And here, all the way here, it's 10 spaces. And if you add 2 plus 10 together, you get 12. And that's 12 steps away. 12. Okay. You could have gone further down, or you can go further left, but we're not going to do that. Okay. And this, we have one more part here. So they're telling us to create a rectangle that has 20 units square. Well, it's not that bad. So let's see if we can create something. So 12 units square means that it's made up of 12 little boxes. So let's just make anything that has 12. Let's take the easiest one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let me see if I can join them. Alright, so if I create a rectangle that's 12 units squared, this would be one of the choices. 6 over, 2 up. There's my rectangle. You could have done other ones, of course. Okay, you could have done a 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, a 3 by 4. And if you connect these, okay. If you count the squares inside, you'll notice that it also has 12. Okay, you could have created another one that's let's see, what else could I have done? 12 by 1. I think that's going to be too popular. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. another rectangle that is 12 units squared. So that's okay. There's a small rectangle. Are there any other ones? 1 and 12, 2 and 6, 3 and 4. That's it. Okay. And from here, such as, okay, wait a second. Did I do something wrong? Yes. Graph a rectangle with 12 units, done, such that its vertices lie in at least two of the quadrants. Well, the only one that I did correctly is this one, actually. This one right here. Because the vertices, I have 2 in quadrant 3 and 2 in quadrant 4. Whereas these, all my corners here are all in quadrant 1, which does not satisfy the question here. And this, all the corners, all my vertices are in quadrant 2. So the only one that I actually did correctly was the last one. Okay. Looks like a kid with braces and, well, anyways. Okay. And then use absolute value to show how you determine the length of the sides. Not too sure what they mean by that. Skip that. Don't worry about that last part. And that's it. So you would label and you actually would, give out the location of each of these vertices or each of these points here, okay, to help you create the rectangle. All right. And am I done? And let's see. Let me just click on the next page. Yes, it looks like I'm done. Okay. That's it. That was easy. Okay. So let's see. Oh yeah. What can I write? Well, you know what? I'm going to go backwards here. Here are your lucky numbers. I don't know why I put there. No, erase that. Instead of a secret word, I'm going to do secret numbers this time around. All these 3 numbers are secret numbers. All right, that's it. We're done. I'm loading it up. It's 7:08. Should be up by 7:30. I'll put that on the website.